हेलो फ्रेंड्स, विंश शताब्दीर 25तम पाहाचरे कंस्ट्रक्शन साइट बहुल मात्रा बढ़ी चली। हेन्स न्यू कॉन्सेप्ट आउ न्यू टेक्नोलोजी रे कंस्ट्रक्शन मध्य चलुची। जुआड़े देखिबो कंस्ट्रक्शन ही कंस्ट्रक्शन। आउ मोर सिविल इंजीनियर भाई भौणी मानकर चाहिदा भी बढ़ी बढ़ी चली। निज प्रोफेशनल लाइफ आउ व्यस्तबहुल जीवन में समय काढ़ा आउ निज पई उपयोग करबा सेते सहज नुहे। कंस्ट्रक्शन तो एमिति चालिबो आउ चालुथिबो। फ्रेंड्स, चलंतु निजको एक्टिव करेइबा। AI कॉर्पोरेट इंजीनियर्स एही चैनल माध्यम रे आपणक विजन, आपणक प्लान, इनोवेशन, प्रॉपर टीम वर्क हेल्प रे स्ट्रैटेजी, टारगेट, मार्केटिंग, ग्रोथ आउ सक्सेस रो निहाती कारण बनिबो। The use of Jaggery and lime in ancient Indian construction is well documented. In fact, these natural materials were used to create a binding agent that was stronger than the modern cement in the many ways. In 17th century India, a binding agent for a stone masonry was made from the lime, jaggery and fresh water. A old construction technique predating modern cement. Numerous examples of the lime, jaggery, water paste are evident in the constructions of ancient temples and residential buildings, showcasing role in this area. In civil engineering, primary component of the concrete is cement. A modern cement production has been inspired by ancient Indian construction technique that utilize jaggery and lime, leading a researchers to develop a more sustainable and eco-friendly building materials. The use of jaggery, lime and fresh water in ancient Indian construction highlights the ingenuity and resourcefulness of our ancestors, while modern cement production has advanced considerable sustainability and durability remains essential principle in the construction industry. There are many types of the cements with basic common properties. We will discuss them all, so please watch this video to the end. We reveal the complete history of the cement, including how Hindustan used the lime and jaggery as binding agent since the 17th century. This video is in the English for our international engineering friends. Please like, share and subscribe to our channel for more informative engineering videos with factory knowledge. So friends, please support us and encourage us with your kindness. Don't forget to subscribe. We had discussed there are the many types of the cements. Commonly we are using the ordinary Portland cements. Let us discuss the complete history of the ordinary Portland cement, patent and its production. The history says Joseph Asdin wasn't the English bricklayer, inventor and stonemason who attained the patent for the Portland cement on 21st October 1824. Cement, as we know, it was first developed by the Joseph Asdin in England. The basic materials used in the cement productions are limestone, ironstone called as the iron oxide, clay, mixed mineral of the alumina, silica and water, gypsum, that is the calcium silicate dihydrate. Gypsum is playing the vital role in cement. The manufacturer process of the cement involves the several stages. Stage 1, raw material extraction. Stage 2, crushing and grinding. Stage 3, mixing and blending. Stage 4, preheating and calcinations. Stage 5, clinker formation. Stage 6, cooling and grinding. Stage 7, quality test, packaging and distributions. Let us proceed with concise overview of the stage 1, that is raw material extraction. Raw materials are typically extracted from quarries or mines by heavy machineries and blasting method, then transported to the crushing plant. Stage 2, crushing and grinding. All the extracted raw material are crushed into a smaller piece, then the crushed material are ground into the fine powder. Size reduction is a critical step in cement production, ensuring the raw materials are properly prepared for the further processing. Stage 3, mixing and blending. Powder formed raw materials are mixed together in right proportions. That mixtures are blended to uniformity and proper chemical reactions. Stage 4, preheating and calcinations. Powder from raw material mixtures is heated to around 900 degrees centigrade in preheated chamber. The preheated mixtures are calcined at around the 900 to 1000 degrees centigrade, which means the limestone decomposed to the calcium oxide and releasing the extremely carbon dioxide. A single line diagram is there for your better understanding, and you can also take the screenshot. Now the stage 5, that is the clinker formation. The calcined mixture is fed into a rotary cylinder based kiln. That mixture is again heated to around 1450 degrees centigrade, forming a small granular size called as a clinker. The clinker consists of the calcium silicate, aluminate and iron oxide. Stage 6, cooling and grinding. The clinker is discharged from the kiln into the cooling chamber. The air is blowing to reduce the temperature. Now clinker is cooled rapidly in this stage. Then the cooled clinker is ground into fine powder and added a gypsum, as a chemical name is calcium sulfate dihydrate. It controls the setting times during the concrete pouring. Now stage 7, quality test, packaging and distribution. Once prepare the cement in powder form, it is usually sent to the laboratory for frequent chemical and physical test to produce the quality pass MTC report, with ensuring the domestic and industrial requirement of the specification. Then the cement powder sent to packaging tower to make a airtight package in respect to the quantity in kg, usually 50 kg per bag. Large quantities of the cements are transported in bulk tankers or silo for the big construction project. The advantage of the bulk distribution can be the more cost effective for large quantity and reduce the packaging waste and can be streamlined logistic. Fresh cement bags now ready for distributing to construction industry for concrete or any cementitious construction items. Cement is primary building material and is extremely important to the construction industry. Then most secondary components are aggregates, as fine and coarse aggregate. It is subsequently added with the cement for concrete. However, that aggregates are approximately 75% of concrete by volume, and water shall be used as per the derived water cement ratio, which is based on the properties of aggregate. For stronger bonding and higher incompressive strength in between of cement and aggregates, we shall maximize the cement content in concrete. In other hand, oil graded aggregate can reduce the cement consumptions as much more cost effective. For proper placing of the concrete and workability, we shall add the admixture in ready mix concrete plant or batching plants. Plasticizer reduce the rate of setting of the cement and increase the workability with pouring the concrete without segregations and excess bleeding of the water. Therefore, it is allowing to reach the concrete in congested area. Self-compacted concrete shall be higher in cement content to achieve the desired flowability and stability. Self-compacted concrete frequently incorporates admixture, including the polycarboxylate-based superplasticizer, to enhance the flowability and reduce the segregations. You can concrete without vibrator or less use of the vibrator. In Odisha, the cement consumption is at nearly 1 million ton by volume per month. It is also expected to grow further, especially considering to the high-rise building construction and government focus on the infrastructure like the metro in coming 10 years. In terms of the growth, Odisha is expected to contribute significantly to India's domestic cement demand by 2029, with a projected compound annual growth rate 7 to 9%, whereas in commercially expected to compound annual growth rate 18 to 21%. Therefore, investing in the cement industry appears the promising for the next 10 years, driven by the India's growing infrastructure needs and housing demand. So current market conditions suggest that investment in the cement industry is now favorable.